Hello, my name is Santiago Villazon, and this will be my video evidence number one. First of all, starting with the description of the application, taking into consideration the name of the class, this being analysis of elements of mechatronics, where the whole purpose is to learn how a mechatronic system operates and works, which is the case of an industrial current. In a system like this, the different parts need to be considered in order to have a properly functioning product as a whole. But the main process behind the creation of an industrial equipment starts by system engineering. This is a way in which the work can be divided into specific groups in order to maintain a correct workflow and efficient production time. For example, in this industrial equipment, we need to have a system as a whole, which is a curtain, and then divide it into different subsystems so that this workflow can be more efficient. Starting with the sensor systems, the requirements for these would be to detect an obstacle below the curtain, to detect the velocity and acceleration of the curtain, to be able to measure the current position of the curtain, and the sensors should be able to detect current and voltage flow throughout the whole system. First of all, the motivation and choices for the sensors are, first of all, the Hull sensor, which the brand is Conrad, which will be able to detect the speed at which the curtain is going up or down. The infrared sensor by UHS hardware, which will detect any obstacles that are below the curtain, and the current meter, which is a brand from Mexico called CDMX Electronica, and the voltmeter, which is from Hydens. These will detect the current and the voltage throughout the whole system. The actuation system. The requirements for these is that the system should be able to pull up and down, pull up the curtain, and the other is to allow the industrial curtain to go down. And the linear, after that, the linear angle of the curtain has to remain constant in order to open and close the curtain correctly. And the angular velocity has to be a factor that the actuator system allows to handle in order to move the industrial current and the speeds that were specified. And okay, regarding the definition of the precise function of the actuator system with the whole control system in the context of the application, first of all, the actuator system should be able to pull up and down the curtain. For this, we have power, force, moment, and velocity for the motor, which is 1 horsepower, 1 newton meter of torque, and 1,755 RPMs. Then the ranges that these go from is from 0 to 1 horsepower, from 115 volts to 230, and also the sensors go from 6.5 to 13 volts. And the power source varies from 115 and 230 volts. With regards to the presentation and motivation for the choice of the actuator, we have chosen a DC motor from a brand called Ferrapad. This motor is capable of lowering and rising the curtain at the speeds that are required. Also, this motor contains the specifications that I previously mentioned regarding the horsepower, the newton meters, and the RPMs. And it has a special system that has a brake in it, so in any case that it needs to be stopped by an emergency, it can stop it without any problem, because it's just built in. And that's also a subsystem that will be coded into the whole control unit, so that this operates automatically or with the help of a professional person that is dedicated to operating the current. Okay, with regards to my personal reflection about these 3 activities, first of all, We know that in any project, we need the so-called system engineering, first of all, which is, dividing workflow to have a more decent operation throughout the whole process of the building and designing of the system. So first of all, regarding the activities, we know that for starting a project, we need the key requirements for the project, like its moving parts, how they need to interact with it, with one another, and the performance of each of these. Followed by that, we need to take into consideration the limits of the physical variables and what they are specifically supposed to do and how these will interact with the subsystem. So basically, it's the performance involved with these parts. And finally, in this phase is where we determine the actual properties of the variables for the actuators and the sensors, which will give us the final definition for the creation of the system. This basically means that we have the specifications for everything. We just need to obtain them and basically build the product that you need to create, in this case, the industrial crane. Thank you very much. This has been my presentation for the evidence number 1.